Yeah, I think it was off. Now only I on it. It will come. You can go live now also. Yes. So I am talking about what is the plan for the coming time. So for the coming days, we are going to revise day by day. That is, every Monday, I am going to take one chapter and I am going to give a revision of that. Quick revision. Don't expect me to teach everything once again. A quick revision. And what are the questions that have come in the past 5 years of the board examination. My aim is to make you aware about how the questions are being asked in the board examination, right? So we will go into the topic directly without wasting any time. Briti, I hope you are able to hear me. If yes, then you can give a confirmation by saying a yes from your side. You are able to hear me, Briti?
Yes, sir.
Okay, fine. We'll go ahead. So in this chapter, the chapter name is electric charges and field, where we are going to study about basic properties of charge. We are going to study about Coulomb's law. We are going to study about electric field, superposition principle, electric dipole, electric field due to electric dipole at various points, torque on a dipole kept in uniform electric field, non-uniform electric field. You are also going to learn about the Gauss law, electric flux, and the applications of Gauss law. This is all about this chapter. Small simple chapter where the questions are mainly coming from Gauss law, its application, dipole and electric field lines. The main questions, if you see, it comes from these headings only. As I said, that is Gauss law, it comes from electric flux, it comes from electric field lines, it comes from electric dipole. Okay? Yes, question comes from every domain. I am saying the important parts from where question is certainly going to come in the board examination. Fine. We will start a chapter, and the first topic in this chapter is basic properties of charges. I hope you remember. What are the properties? Tell me fast. 3 properties are there. What are those properties? Quantization, additive nature and conservation. There are 3 properties. First one is called as additive nature. The second one is conservation. And what is the third one? Quantization. These are the 3 basic properties of charge. What is the meaning of additive nature? Additive nature says that charge on a system or on a body is the algebraic additions of all the individual charges, right? Like 2q, 4q, 6q, minus 10q, minus 8q, 11q. If you add everything algebraically, then you get what is the total charge on the system. That is additive nature. Next is conservation. Conservation says that you cannot create charge, you cannot destroy charge. When 2 bodies are brought in contact, they transfer the charge equally inside between them if their sizes are same. If sizes are not same, based upon their size, they divide the charges in that ratio. For example, if there are 2 objects having, like one is having r, one is having radius 2r, and when they are brought in contact, and if it is having a charge of 100 Coulomb, then don't think it will share 50-50 Coulomb. When they are brought in contact, they will share in the ratio 1:3. 1:2 actually, 1:2. So it will be 1/3 of 100 and one will get 2/3 of 100. Am I right? So in this ratio only, they will be sharing the charges among them. This kind of questions can also come. Then we have quantization. Quantization says that Q is equal to NE, where the net charge on a body is integral multiple of basic elementary charge. Now what is this basic elementary charge? It is the charge carried by a single proton or a single electron. Any charged particle, how much charge it carries, that is known as basic elementary charge. So if you have 10 protons, total charge will be 10 multiplied by 1.6 and 10 to the power minus 19. If you have 1 million charge, 1 million protons, then 1 million multiplied by this basic elementary charge. So when you multiply the basic elementary charge with the number of charged particles, then you get total charge on a body, right? So these are the basic things about properties of charge, and from here how can you expect the questions to come? So the questions from this topic are coming in 2-3 categories. One category is they will ask you that how many charges are there in a particular thing, like 1 glass of water. I have often asked this question in the class. 1 cup of coffee, 1 cup of water, or 1 glass of a chemical. Anything they may ask you, you have to be very well aware about the mole concept. If you are not knowing mole concept, this kind of questions you cannot take. That is, if they ask water, 100 gram of water, how much charge it has, then first all you should do, you should try to find 100 gram of water has how many molecules of water. How do you find it? By using mole concept. You know that 18 gram of water has Avogadro number of molecules. Then 1 gram of water will have Avogadro number by 18. 100 gram of water will have Avogadro number by 18 into 100. You will get number of molecules. Now, each molecule is having how many positive charge? Hydrogen will have H2O. So, hydrogen will have 2 positive charge, oxygen will have 8 positive charge. So, 10 positive charge in each molecule of water. How much of molecule you get? Multiply by 10. Then you will get total number of positive charge. Then you multiply with E. You get the total charge, total positive charge in 100 gram of water. Isn't it? This kind of questions can come. One category. Same way they may give HCl molecule or anything they may give like that. So, they may give you 100 ml of HCl acid. How much positive charge it has, how much negative charge it has. They may ask questions like this also. So, whatever it may be, you have to solve by using the mole concept there. Next comes this category of question. I told you already. Two bodies are brought in contact. How much charge gets transferred between them? This kind of question also you can solve if you are knowing the size will divide the charge in the same ratio of their sizes. If they are equal in sizes, yes, 50%, 50%. If they are unequal, then based upon what is their size, the charge gets divided. If it is 1 and this is 4, then it will be 1:4 ratio only division, right? Third category of question is possibility of charge, whether this much charge is possible or not. Whether 3.2 into 10 to the power minus 20 Coulomb charge possible, like that questions will come. Where Q is given, E is known to you, divide Q by E, get N. If N is an integer, possible. N is a fraction, not possible, right? That is the way you check whether a charge is possible or not. These are different kinds of questions that can come in the examination. Let us take one question that has come in the previous examination. It has come in 21-22 examination. See the question. I hope it is visible to you. Briti, Shivani, is it visible? The question on the screen?
Yes, sir.
Okay. The question is, anybody can try. I'll give 2 minutes for each question. I'll give some time for you to solve, then only I will solve. All of you please give a try. Simple question. Read the question and give a try. No need of writing anything. Just read and try. A negatively charged object X is repelled by another charged object Y. However, an object Z is attracted to object Y. Which of the following is the most possibility for the object Z? Actually, it is not from basic properties, but basic concept of charges. This question is there. Oh. Tell me the answer. A, B, C or D? Fast. A. Balan says A. A.
Sir, option D.
Oh. Briti says B. A. Adityan A. Adarsh? A. C. Very good. C. C. Asking your answer. C. Okay. So we have option A also, we have option B also, we have option C also. Reading question properly? Visible, Adityan? They're also saying A. A negatively charged object X is repelled by another charged object Y. X is what charge? Negative charge. It is repelled by whom? Y. So what will be Y's charge? Positive. Repelling, no? Y should be negative only, obviously. However, an object Z is attracted to the object Y. Now please pay attention. So if there is an object Z and it is getting attracted to whom? Y, you are saying it must be positive? Yes, obviously correct. But what if it is neutral? It not get attracted. If you take a scale and you rub in your hair, scale gets charged. When you bring in front of the small piece of paper, whether paper will not attract it? It will attract, no? Whether paper is charged? No, right? Paper is neutral. In neutral object also, the positive charge will get attracted towards negative and the negative will be repelled by the negative. Are you getting my point? So many of you will tick A and come in the board examination. What will be the answer? C. Neutral or positive. Understanding? This kind of question. Simple, looks simple, but people do mistake in this. It can be positively charged also. It can be neutral also. Why it should be neutral? Because neutral bodies are also attracted by a charged body. Remember this. I hope it is clear to you. Next question. Next question is this. Pay attention once again, interesting question. Let me see how many of you are able to solve this. In an experiment, I hope it is visible to all of you. Visible? Yes, then try to get the answer for this. They have converted into image. Okay, anyhow. In an experiment, 3 microscopic latex spheres are sprayed into a chamber and became charged with charges +3, +5e, -3 respectively. all the three spheres came in contact simultaneously for a moment and got separated. Which one of the following are possible values of the final charge on the spheres? Now, this is from properties of charge only, and this question has come in the board examination 21-22. Think and say A, B, C or D. Actually, there will be confusion in this question. See, you will understand. Once again, a simple question with some confusing elements inside. Answer? Try, man. Wrong or right is secondary. B. Okay. So, Adarsh says B. Okay. A. Gokul? A. Then? Still reading. Read, no problem. C. Okay. I'm not saying anything. Okay, okay, and I'll say. Huh? B. Okay. Yes, tell me, please.
Option C.
Option C. Okay. Option B. You said B only, no? Anybody else? I have B, some people, and some people have said C also. Anybody else? Balamurugan, something they are speaking, I will listen. Try, man. Not tough question. Definitely it can't be C.
Because n cannot be correct.
Obviously.
Huh? Add in B only getting pi as mentioned.
Now please pay attention. Very simple question. What you should have done, you should have added these three, right? Plus 5 plus 3 minus 3. You would have got plus 5e. And you will check which among these 4 is giving plus 5e to you. Bad thing is, B will also give, C will also give. If you add B, plus 6 becomes 12, 12 minus 7 becomes 5. 5e it gave. Here plus 3.5 plus 5.5 becomes 9, 9 minus 4 once again becomes 5. So C and B are giving the same answer. But as you told, 3.5, 5.5 is possible, Priti? Sanjeet, possible? Can you have 3.5 protons? Or can it be an integer? I told or not? Q is equal to NE, where N must be what? N must be integer. If N is not integer, then what? Then you cannot expect the charge possibility. So 5.5e, 3.5e are not possible itself. So the correct answer will be B. Understood? B is correct. Good. Both questions that I gave is 1 mark question. Both questions that I gave are simple question. But both questions you are having mistakes from your side. Are you feeling why? Because small things matters in board examination. Question will not be tough, but the concept must be very clear. Now this question teaches you about quantization. Right? Can I proceed further? I hope I can. Okay. Next I will go. Next we will talk about Coulomb's law now. What is Coulomb's law? Very simple, most established law known to everybody from very small age. Coulomb's law says that F is equal to K Q1 Q2 by R square, where Q1 Q2 are the charges and R is the center to center distance between them. Obviously, nothing big in this. There are two charges, one is Q1, another is Q2, and distance between them is how much? R. Then the force of attraction or repulsion between them is K Q1 Q2 by R square. Again, I am not deriving and telling all these things. Time is not there for that. Where K is what? 1 by 4 pi epsilon naught. What is epsilon naught? I'm not asking the value, meaning of that. Epsilon naught is permittivity of free space. Permittivity means what? Permittivity means the permission given by the medium to interact. So free space, what permission it is giving is called as permittivity of free space. And its value, as you know very well, not a big thing, 8.85 10 to the power minus 12. What will be its unit? Its unit will become equal to Coulomb square meter power 2 Newton minus 1. Am I right? This is the unit of epsilon naught. So, epsilon naught is the value of permittivity of free space. If you keep both these charge in some medium which has some permittivity epsilon, then the force between, this is the force when there was no medium in that, that is F naught was 1 by 4 pi epsilon naught into Q1 Q2 by R square. What if there is a medium between them? Which medium? You can take the medium as something which has a permittivity of epsilon. Then I will get the value of Fm as, Fm will become equal to 1 by 4 pi epsilon of the medium into Q1 Q2 by R square. Here epsilon will become what? Epsilon will become permittivity of the medium. Understanding? Epsilon naught was permittivity of free space. Epsilon will become permittivity of medium. If I divide these two, that is, if I do Fm by F naught, what do I get? Epsilon naught by epsilon. Or I can say, no, not this. F naught by Fm will be how much? Epsilon by epsilon naught. This is called as epsilon R. It has another name, K, kappa, which is dielectric constant. That is the ratio of the force between two charges when they are kept in free space to when they are kept in some medium. That ratio of forces is called permittivity, relative permittivity. In the exam, the question will come, it may come, define relative permittivity or define dielectric constant. And if you say dielectric constant is the ratio of permittivity of the medium to permittivity of free space, 0 mark they will give in the board examination. Remember that. If you want to get marked, you should not write in terms of epsilon. Conceptually, you are correct. But definition wise, definition of dielectric constant is ratio of the forces between two charges when they are kept in free space to when they are kept in some medium. So, this epsilon R, also called as kappa, that is dielectric constant, is equal to epsilon naught, actually epsilon by epsilon naught, isn't it? Epsilon by epsilon naught. Can I say like this? I hope it is clear to you, is it? Any doubt? So, whenever you want to find the permittivity of any medium, you have to multiply its dielectric constant with its permittivity of free space. They may give you, they will never give you epsilon value directly. They will give you K value or epsilon R value. Multiply these two, you will get epsilon value. Yeah, they may give force value also, whatever it may be. So, I hope you are getting what is the meaning of Coulomb's law. And this is Coulomb's law in scalar form. Another thing is Coulomb's law in vector form. And this law, whatever I told you, it is applicable for two charges, isn't it? If you have two charges Q1 and Q2, whatever be their magnitude, whatever be their direction, that is plus or minus, you can use Coulomb's law and get the value of force. Problem comes when you have more than two charges. For example, you have charges like this. One charge here Q1, another charge here Q2, another charge here Q3, another charge here Q4. And they may ask you, what is the net force on Q4? Or what is the net force on Q5 placed at the center of the square? This kind of questions can come. They may give a value, plus 2 Coulomb, minus 2 Coulomb, plus 9 Coulomb, plus 8 Coulomb, whatever it may be. And they may ask you, what is the force on this particular charge or this particular charge? Here, you will take the help of vectors. If you are not knowing vectors, quit this topic, because now you cannot learn suddenly vectors. If you are knowing vectors, it is very simple. For example, in this question, suppose I am taking the values, suppose I am taking plus 2 Coulomb, here minus 2 Coulomb, here minus 5 Coulomb, here plus 5 Coulomb, just taking some random values, and Q5 I am taking as plus 1 Coulomb, okay, and I am taking the square has a side of 1 meter by 1 meter. 1 meter by 1 meter square The charges are +2, -2, +5, -5, and you are going to have, you have to find the value of net force on Q5. Now this Q1 will be repelling Q5, am I right? Why it is repelling, your understanding? Because plus, plus. I am writing it as F1. What about Q3? It will be attracting Q5, am I right? Why? Why it will be attracting? Because it is positive, opposite. Q4 will be once again repelling, isn't it? This will be F4, and this Q2 will be once again attracting. It will be F5. Do you agree with me? So not F5, I am writing it as F2. F2. Now you have F1, F2, F3, F4. F1 and F4 values you know. How much is F4 value? F4 value will become equal to K into 1 into 5 by this square. This will become how much? I think it will become 1 and 1, so it will become √2. So √2 by 2, 1 by √2. So 1 by √2 square you will do. You will get the value of F1. Same way you will get the value of F4. You will subtract both, you will get net force. Same way you will find F3, you will find F2, subtract both, you will get net force. Based upon which direction it is coming. Suppose you are going to get net force towards this direction, and for this case towards this direction, and this is F14 and this is F23. The net force will be somewhere here, which will be F14 square plus F23 square plus 2 F23 F14 cos 90 degree. Why, man? This case how 45 it will be? 45, 45, 45, 45. 90 only, no? Are you getting my point? I hope you are understanding this. This kind of questions can come. Are you getting? Or a triangle based question can come, where they may ask you to find the net charge. This question also came in the board examination. Which one? The triangle and finding the net force in the centroid of triangle, or a triangle in which they are asking you to find the net force on this charge or this charge. NCERT has these examples. This kind of questions have come in the past board papers also. I will show you now. So I hope you are understanding how the questions are coming from Coulomb's law, right? Shall we take from the past papers how the questions have come? We will take it. So first question, very simple question again, think and solve. Whatever questions I have chosen are little challenging question. It looks simple, it will have some twist inside. Try. I hope it is visible to everybody. Give a try. If you are not able to see clearly, you can sit there also. Oh, then fine. Oh.
Sir,
Yes, please.
instead of displaying the questions in the corner, if it is in the center, it would be.
It will be good for you, but now this has been made as an image. I cannot move it. I try to move it actually, but I am unable to move it now. Is it not visible to you?
Yes, sir, it's visible, but the corner is on the right from me.
Oh, but sorry, I cannot help you now because it is an image. I cannot move that part. Okay. If you want, I will read question for you. Shall I read it or you are able to see?
Yes, sir, you can read it.
Okay. The question is like this. 4 objects W, X, Y and Z. W, X, Y and Z, each with charge plus Q. All the 4 charges are having charge plus Q only, are held fixed at 4 points of a square of side D. So square is there. I am drawing it for you, Priti. Okay. So there is a square, and square has a side of D. This side, and obviously this side also D. And they are saying there are 4 points. One point is here, one point is here, another point is here. They are naming the points. They are naming the points as W. Here they are naming it as X. Here they are naming Y. And then they are saying charges plus Q everywhere. Plus Q, and here somewhere in the center you have Z. It is also having charge plus Q. Object X and Z are on the midpoints obviously. So X and Z both are in the midpoints, d by 2, d by 2. The electrostatic force exerted by the object W on object X is F. So how much force the object W is exerting on the object X? This force, they are positive, so they will be having repelling force. This force is given as F, right, Briti? Now they are asking, what is the magnitude of force exerted by the object W on Z? So W will exert a force on Z in this direction. They are asking what is the magnitude of this force. In terms of that force, I am writing it as F dash. Good question. 1 mark only. See, MCQ question. But this question came in MCQ category of 21-22 paper. If you have understood the question, solve it. B, F by 5. Okay, let me check. I'm not saying you're right or wrong, but Adarsh says it is B. Anybody else? Give a try, give a try. Give a try if you may be right also. I'm repeating, question is easy. It looks like this, but question is easy. Anybody else? Any answer? Rahul, if you are able to hear me, your video should be on in this class. Whatever, man, keep it, man, whosoever. Anybody else? One answer is B by others. Huh?
Give us 2 minutes.
Okay. 2 minutes, too long time for this 1 mark question. Okay, anyhow, fast. D. Okay, so Bharat Khanna says D. Karthikeyan, no idea? But they're not solving itself. B. B only. Soumya? B. These people not solving here, waiting for me to solve. It's simple. I am solving parallelly. If you want, you can also solve. Yes. So it is Q, and distance how much? This is D by 2. This is D. So this will be how much? Hypotenuse. How much will be that? Root over D square plus D square by 4. Am I right? So this distance will become equal to root over 4, that is 5 D square by 4. Am I right?
No need to square.
No need of squaring.
However, you are going
Okay, but this will be the value of hypotenuse, right? Now, we are going to find the force. The F dash value will become equal to K Q by R square. What is R? Square of this, which will become equal to 5D square by 4. Am I right? So, when you solve this, it will become 4KQ square by 5D square. Do you agree? Do you agree what I have done? And in this case, the F value, what is the value of this F? We can find it. This F is given by KQ square by D by 2 the whole square, which will become D square by 4 I am taking above. So see, compare these two. 4KQ square by D square, 4KQ square by 5D square. Very easily you can see that F dash by F will become equal to how much? F dash by F will become equal to, put 4, I am solving very deeply for some people who are not understanding. 5D square multiplied by F, F will become equal to D square by 4KQ square. These two gets cancelled. Once again I took 5 here. Yeah. D square gets cancelled. I am getting 1 by 5. So F dash becomes equal to 1 by 5 times of F. That is the answer. B is correct. I hope you are understanding.
Yes, sir.
Not understanding? Understood, no? Got the answer? I hope no doubt is there. Simple question only. Can I proceed further? Can I proceed further? Next question. Once again. Make it fast. Question has come in the board examination. 2019 it came. 2019 question. Simple question only. Give a try. It's a 3 mark question, I think. Two identical point charges Q each are kept 2 meter apart in air, a third point charge capital Q of unknown magnitude and sign is placed on the line joining the charges such that the system remains in equilibrium. Find the position and nature of Q, small q. Give it a try fast.
So Q, small q will be 4 times of
Capital Q.
capital Q.
Okay. So the answer is Q is equal to 4Q. And its nature? You told the nature position?
So position is, it's in the midpoint of the joining
Midpoint.
of the two charges.
Okay, so it will be x is equal to 1 meter.
Yes, sir.
Agree?
Both are negative and that is positive. Center it is positive. And Q are negative. Small q are negative.
Okay, so you are telling that Q both are negative and the plus Q is positive. Okay, why can't everything be positive? Possible, no? What you are saying also is possible.
Then how to find?
I'll tell you. No, it's not like the question should have only one answer. Both options answers can be right. Charge Q, another charge Q, and having a distance of how much?
They told about the charge of small q means the question is not.
And they're not told, no? Why they want to make it easy for you? So Q and Q, a third charge Q of unknown magnitude and sign is placed on the line joining the charges such that system remains in equilibrium. Where we kept, we don't know. Let us assume they kept at x distance away. What will be the remaining distance? 2 minus x. And what I am keeping? I am keeping a charge capital Q there, right? Now force by this Q, if I am assuming positive everything, it will be repulsive here. This Q, once again repulsive. If I am taking it as F1 and F2, then F1 must be equal to F2 for equilibrium, am I right? I am solving step by step, 3-mark question this is. You have to write steps properly. So what is F1 value? F1 value will become equal to K Q capital Q by x square. Do you agree? Same way, what will be the value of F2? K Q into capital Q by 2 minus x the whole square. I hope you agree. This 2 gets cancelled. And I am getting 2 minus x by x the whole square is equal to 1. Can I say like this? Just solving the equation. After that, it will become like 2 minus x by x is equal to 1. And so 2 minus x becomes equal to x. X and x will become 2x. 2 becomes equal to 2x and x becomes equal to 1 meter. Obviously, by common sense also we can say the answer is 1 meter. Without solving anything, it has to be in equilibrium. So k q q by 1 square, k q q by 1 square. Without even solving these steps, by common sense you can say the answer is 1 meter. But they won't give marks for common sense for 3 mark, isn't it? They want you to solve it, explain it, get the answer. So this is the way of solving it. Force on capital Q because of small q, k q q by x square and k q q by 2 minus x the whole square. If you solve it properly, then you will be able to get the answer. It will come same as you are thinking, 1 meter only. So position, and what is the nature of charge Q? If you want, you can say that it will be positive if capital Q is positive, isn't it? And both charge can even be negative, because if they both are negative, what will happen? This Q will be attracted this side, this Q will be attracted this side, isn't it? Both should not be different. One positive, one negative. It's not possible. So either both Q are positive or both Q are negative. It can be both. If capital Q is positive or negative. Are you getting? Position is 1 meter. Is it clear to you? Simple question. Can I go to the next question? Shall I? Again. Okay, before I go, electric field we will discuss. So, what is electric field? What is electric field, guys? You don't know or you are not saying? Force per unit? School they gave that, huh?
Force per unit.
What you are having in your hand, school gave? Huh? Okay, good, good. So, force experienced per unit test charge, isn't it? Very good. You should remember like that only, that electric field is equal to F by Q naught. What is the meaning of it? Meaning is, whenever you have an existing charge Q, whenever you have an existing charge Q, and if I bring another charge Q naught in its nearby, what is its force experienced per unit charge? That is only known as electric field. So, electric field, what will be its unit? Newton per Coulomb. Newton per Coulomb, it has another unit. What is that? Volt per meter, yes. So, Newton per Coulomb or volt per meter, both are the SI unit of electric field, right? And electric field, since it is force per unit test charge, force can also be written as Q naught into E, isn't it? It means that if any test charge Q is kept in the electric field, that charge Q will always move in the same direction of electric field, because the force direction and electric field direction is going to be same if charge is positive. If charge becomes negative, the force experienced by it will become in the opposite direction. That is why if you have electric field, for example, electric field is like this, in this direction, and if you place a positive charge here, it starts moving in the same direction. If you keep a negative charge here, it starts moving in the opposite direction, right? Because F becomes minus QE in the case of negative charge, F remains plus QE in the case of positive charge. I hope you are remembering that. Another thing I will tell you, that whenever the electric field, if you are understanding, suppose there is a charge Q, what will be its electric field lines? It will be radially outwards. I hope you know this. You would have heard somewhere in some books written that electric field lines are closed continuous curves. Am I right? Electric field lines are closed continuous curve. If it is not continuous, what will happen? Why it should be continuous?
At the point there will be two directions.
Not, you are talking about intersection. No. You are giving the answer for why two electric field lines cannot intersect. I am asking something else. I am asking like, why can't electric field be line like this and like this, discontinuous? Is it possible? Can electric field line be like this? No, it must be continuous. Why? What if it is discontinuous? This question has come in the board examination. See, electric field represent the direction or the path in which a charge will move when it is kept in the near this charge. Suppose I am keeping a Q naught, if I keep it here, it will move like this. If I keep a Q naught here, it will move like this. If I keep a Q naught here, it will move up to here, then what? It will jump. It cannot jump, no? Which is not possible. So, the line must be continuous line. This is the answer. What you should write? If the lines are discontinuous, then a charge which is moving in the electric field of an existing charge will not be able to continuously move. It will have to jump to once again come to that electric field line, which is not possible. So, the electric field lines must be continuous. Are you understanding this? A charge cannot go like this, jump and go, not possible, no? It has to move in the same path. So, electric field lines represent the path in which a test charge will move if it is kept in presence of an existing charge. Are you getting my point? You want me to tell it? Electric field lines are the path in which a test charge moves. Path in which a test charge moves in presence of an existing charge. In presence of an existing charge. Okay. So, electric field general formula I have told, F by Q. If you put the value of F here, you will get the electric field due to point charge. How much will be that? K Q by R square. Very, 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 very important. It means if you have a charge Q and you have distance R, you can easily find R distance away how much is the electric field, isn't it? If I say you 10 Coulomb charge 1 meter away, how much electric field? 10 K by 1 square. 10 Coulomb charge 5 meter away, 10 K by 25. 10 Coulomb charge 10 meter away, 10 K by 100 Newton per Coulomb, right? This formula helps you to find the electric field due to a point charge, and very similar to Coulomb's law. Here also you may get two kinds of question. One kind of question can be, if you have two charges, find the point where the electric field is 0, right? They may give you plus 5 Coulomb and they may give you plus 10 Coulomb, and they may ask you where between them, distance between them may be given as 4 meters, where between them or at which point between them is the electric field 0. Yes, it can be. Wherever you want to find the electric field, keep a test charge Q0. This plus 5 will give a repelling force. This plus 10 will give a repelling force for the net repelling electric force, obviously. So, net electric field to be 0 here, what will happen? K into 5 by x square must be equal to K into 10 by 4 minus x the whole square. When you solve this, you will get the value of x. One kind of question. Second kind of question that can come from here is superposition based question. That is, once again, they will give you a triangle and they may ask you, in centroid of triangle, what is the electric field? Or they may give you a square, they may give you charge here, charge here, charge here. What is the net electric field at this point? Or they may give you a square, a charge here, a charge here, a charge here, a charge here. What is the electric field at the center of the square? Are you understanding? In all these cases, suppose Q1 is given to you, Q2 is given to you, Q3 is given to you, keep a test charge here, suppose positive, positive, negative, based upon direction, repelling, 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 suppose. Then you will solve and get the answer, isn't it? Same way here, suppose it is plus 5 Coulomb, plus 5 Coulomb, minus 5 Coulomb, plus 5, minus 5, plus 10 Coulomb. This plus 10 will give a repelling field, minus 5 attractive field, plus 5 repelling field. All these three, solve these two first and then it will come in this direction, add these two things, get the answer. Are you understanding? Same way here, plus 2, minus 2, plus 5, plus 10. This plus 2 will give a repelling field, minus 2 attractive field, plus 5 repelling field, plus 10 repelling field. These two you add, and then these two add, it will be in the same direction. These two you solve, it will be in this direction. Then this and this you solve, it will be in this direction. It will not come as much complicated, but I was telling you, you have to use the vector rules to solve the electric field for multiple charges, same way how you solve electric force for multiple charges. Is it clear to you? This is another way of solving this. So now let us see how the questions have come in the past. This question has come in 2023 board paper. Please check how the question has come. The magnitude of electric field due to a point charge at a distance of 4 meters is 9 Newton per Coulomb. From the same charged object, electric field of magnitude 16 Newton per Coulomb will be at what distance? MCQ question came in 2023. Make it fast. Hmm? 3 meters. Okay. Solve it. What is the answer? Tarun? 3. So Tarun Vishwajit says 3. Anybody else? Any answer? 3. 3. Okay. I hope 3. Okay. So electric field is equal to kq by r square, am I right? kq by r square. So for the first case, they gave the value of E1, how much? 9. And the value of charge is given, not given. kq, distance is given, 4 square, isn't it? Then they are asking, if it is 16, then same charge, what is the value of distance? This is the question. This is the question, right? Divide 1 by 2. Always this kind of question, divide 1 by 2. Then you will get 9 by 14, so 9 by 16 is equal to what? R square by 16, isn't it? Obviously, yes, if you divide both. 16, 16 gets cancelled. R square is 9, what will be R? 3 meters, isn't it? This is the answer. Are you getting? See, questions I am telling you again, if your concept is clear, no, you cannot have very tough questions on this chapter, any chapter. Shall I go to the next page? Shall I go to the next question? I hope you have understood this. kq by r square based question only. Shall I go to the next page? Tell me fast. Okay, thank you. See this question. Last year question is 2024 this question came. 3 mark category. NCERT book question, you know. What is PC? Minus 12. Picocoulomb. Picocoulomb, 10 to the power minus 12. Any answer? Answer is 0. At least you remember good. Answer will be 0 only for sure. But 3 mark question, you cannot say the answer as 0 and get half mark they will give you for the answer. You have to solve it, right? Huh?
121.
Yes, yes, same thing as you are thinking. Answer is 0. I agree to it. But you have to prove it. I hope you are trying to solve. Please, please, let it be a practice. Make a triangle. Keep 1 picocoulomb, 1 picocoulomb, 1 picocoulomb at the vertices, and then try to find the electric field at the centroid. Give a try. Ten centimeter means 0.1 meter, right? This is the question. You know what I'll recommend? I'll recommend to take it like Q, Q, Q and R, R. That will be more easy. Instead of taking it as 1 picocoulomb, 10 to the power minus 12, 0.1 meter, confusing in solving, take it as Q, this as Q, this will also become Q because all are same. And let this be R, this will also become R because it is a equilateral triangle. Now find the centroid. What is centroid? Centroid is the point where all the what? Medians of a triangle intersect, isn't it? So if this is R, what will be this? R by 2. Am I right? This will be R by 2. And if it is equilateral triangle, this will be 60 degree and this will be 30 degree, right? Now very easily you can find its distance because you have got a triangle where this is r by 2, and this is 30 degree. You can use trigonometry and you can find this. If this is A, B and C, you can easily find AC, isn't it? Cos theta. What is cos 30? In this case, B by H. So R by 2 and H is AC, isn't it? So what is cos 30? Root 3 by 1 by 2. Root 3 by 2. So root 3 by 2 will become equal to R by 2 AC. 2 gets cancelled. You get the value of AC as how much? R by root 3. Helps you. How it helps you? Because you want this distance only. I have taken this point as A and this point as C I have taken. Let this point be D, let this point be E. So what will be the AC? Same will be AE, same will be AD, isn't it? So this, if I keep a test charge here, it will experience a force in this direction, let it be E1. It will experience a force in this direction, let it be E2. It will experience a force in this direction, let it be E3. Am I right? I hope you are understanding whatever I am doing. After this, E1 and E2, you have to solve. See, once again, what is the value of E1? E1 will become equal to K Q by R, no, R by root 3. R by root 3 square. Am I right? What will be E2? Same. What will be E3? Same. Because charge is not changing, distance is not changing, electric field will not change. So for these two, E2 and E1, if you find what is the net electric field, that will be in this direction, and what will be that? I am taking it as E23, sorry, E21, E12 I am writing. E12. What will be E12? E12 will become equal to root of E1 square, I am taking it as E itself, E square plus E square plus 2E square cos how much? Cos 120. What is cos 120? Minus 1 by 2. You should remember by now. So minus 1 by 2 will cancel. E square plus E square minus E square. This 2 gets cancelled. Root E square will become how much? E. So down also you have E. Up also you have E. They will cancel each other and net electric field at A will be 0. This is the answer. No doubt in that. But all this is a 3-mark question. If you don't write these steps, they will not give marks to you. Is it clear what I have done? Centroid based questions are coming in the board examination. And cos 120 is very common in physics, I have told you already. Shall I proceed further? I will share the PDF with you if you want to refer the notes. No problem in that. Next question. Pay attention. 2019. Good question this is. Draw and show me, all of you. Draw the pattern of electric field lines when a point charge minus q is kept near an uncharged conducting plate. All of you draw and show your notebook like this to me. This question has come twice in board examination. One time minus q, one time was plus q. Why are you drawing the plate, man, this much time? Just draw straight line, fast. Over. Electric field lines you have drawn. The electric field lines they are asking you to draw. Yeah, Priti? They are not asking you to draw just the plate and the charge. You should draw the electric field line. Wrong, 0 marks. No? 2-mark question this is. Wrong. What we are doing, man? 0 mark. Only plate. No, wrong. 0 mark. There, very good. Wrong. 0, 0, 0, 0. Something he knows. But okay, some marks can be given, not full marks. 2-mark question this is. 1 mark can be given. Anybody has done this? Shall I not mind? See, again I am repeating a question that has come twice in the board examination. There is an uncharged plate. Uncharged plate means equal amount of negative positive. There is a negative q charge here, right? Negative Q charge will have radially inwards electric field. So radially inwards electric field like this, isn't it? Do you agree? But here it will attract all the positive charge. So electric field lines will be from positive to negative. Are you understanding? This diagram, if you have drawn, full mark. You have drawn up to here. You have not drawn this side, right? Required for the examination. If question comes plus Q and an uncharged plate, how it will be? Plus Q will have radially outwards, and it will attract once again what? Negative side, isn't it? So we will draw like this, and what will be here? Negative. And what will be here? Positive. For this question, you should draw this only, don't draw both. But this kind of questions are coming. They may ask you, draw the electric field lines of a dipole, a plus charge, a negative charge. How you will draw? From positive to negative. Positive radially outwards, negative radially inwards. Am I right? This kind of questions are coming in the board examination, guys. Take it seriously. The electric field lines diagram. Is it clear? And this question has come twice, I told you. Shall I proceed further? Shall I proceed further? Yes or no? Okay. Next topic. Electric dipole. What is a dipole? What is an electric dipole? Two equal and opposite charges separated by a small distance taken as 2D mathematically. There is no significance of 2D much theoretically. Only for solving numerical it will be easy for you, nothing else. So what is a dipole? You have two charges, magnitude plus Q and minus Q, and having a separation of 2D, 2A, 2L, whatever you want you can write. Now my question to you is, what is dipole moment? Loudly? Strength of dipole, very good. Strength of dipole is given by dipole moment. What is the magnitude of it? What is the formula of it? Q into 2D. Dipole moment P will become equal to Q into 2D. Remember that? So what will be its unit? Coulomb meter. Coulomb meter is the SI unit of whom? Dipole moment. Okay. Now my question to you is that what is the direction of dipole moment? From negative to positive. Always remember this, that dipole moment is from negative to positive. I am writing P cap here. From where to where? From negative to positive. Always remember this. Dipole moment direction is from negative to positive. Fine. Now, this dipole, there are two kinds of questions that can come in the examination. One is from the electric field due to electric dipole at axial point, at equatorial point. Second is electric dipole placed in a uniform or non-uniform electric field. I will repeat, electric dipole placed in uniform electric field or electric dipole placed in non-uniform electric field. Based upon that, questions are coming. I will talk about both now. So first let me talk about the force or a torque experienced by the dipole. So suppose you have a uniform electric field. I am drawing like this. What I am drawing? A uniform electric field I am drawing. In this uniform electric field, if I place a dipole, which is minus Q and plus Q, it will be having dipole moment from negative to positive like this, direction of dipole moment P cap, and distance is 2D between them. What will happen to this dipole? This dipole will experience a torque, not a force. Why torque? Because this plus Q will be having a force in this direction. How much? Q E. This minus Q will be having a force in opposite direction. Magnitude same, Q E only, but minus. Minus means opposite direction. Now on an object, if you have two forces which are having same magnitude but opposite direction and opposite different lines of action, it will make the object to have a torque, isn't it? Rotate. No net force because QE minus QE 0. Translatory force is 0, but rotational force is there. How much is that? Torque tau is equal to Q into 2D. Sorry, what I said? torque will become equal to PE sin theta. That is, you have to find force multiplied by perpendicular distance. And when you solve this, you will get finally tau is equal to PE sin theta. P sin theta, or you can say P vector cross E vector. How the questions can come from here? Questions can come, I will tell you different types of question. One question can be, which position of electric dipole will lead to maximum torque? What will be the answer? Theta is equal to 90 degree. Which position of dipole will lead to zero torque? Theta is equal to 0. This is torque minimum. This is torque maximum. Don't write minus 1 is the value. It's not like that. You may think which value is having minus 1, that angle should be there. It's not like that. 0 torque or maximum torque. 0 torque is for 0 degree. 0 degree means what? Parallel or anti-parallel, because even theta is equal to 180 degree, it will be 0 only, no? Sin 180 is also 0, am I right? So, if a dipole is placed parallel to electric field or anti-parallel to electric field, it will experience no torque. And if it is placed perpendicular to electric field, it will experience the maximum torque. Now, don't think that because of this torque, dipole starts to rotate like this. No, never. It will just align itself in the magnetic electric field, isn't it? So, if it is like this, it will become like this. That's all will happen. Because once it becomes like this, theta becomes 180 degree or 0 degree, no torque, 0. Are you getting my point? So, dipole, what it will do? It will just align the electric field. What it will do? It will align the dipole in the electric field. Are you getting my point? Electric field aligns the dipole in the same direction of electric field. What if the electric field is non-uniform? It will experience a torque as well as translatory force, because the value of QE and this QE will not be same. Non-uniform electric field means it will be QE1 and QE2. If it is QE1 and QE2, what will happen? They will be having different value of forces also. It will not be 0. So, in addition to torque, we will also experience a translatory motion. It means if there is uniform electric field, it turns like this. Non-uniform electric field, it goes and turns like this. Are you getting a difference? If it is uniform electric field, dipole will turn like this. If it is non-uniform electric field, it will turn like this. I hope it is clear to you. Understanding? Okay. Next category of question that comes from the dipole is finding the electric field due to electric dipole at axial point or at equatorial point. Again, I am not going to derive it now, but I will just tell you how to derive it. The question comes in the exam. Plus Q, from center of dipole, go r distance away and find what is the value of electric field. This is called as E axial. So, what we will do, we will keep a test charge here. This plus Q will give a repelling field, minus Q will give a attracting field. Subtract both, you will get net electric field. And when you solve it and get the answer, you will get the value of E axial is how much? Anybody remembers? It is K into 2 P R by R square minus D square, the whole square. D is this distance, half distance, D and D, isn't it? And if you want to write in vector form, what will happen? Obviously R vector, and here P cap will come. P cap means it will be having the same direction as that of the dipole moment. Obviously, yes, because dipole moment from negative to positive, P cap, and this is also from this direction. Net electric field will be in this direction, E axial, isn't it? So, I am writing the P cap value, and if R is much more than D, then what will happen to E axial? It will become K into 2P by R cube. Understood? Same way, if you want to find the electric field due to electric dipole at an equatorial point, what is that point? Equatorial point is for a dipole, I am going where? R distance perpendicularly away from it, here. Minus Q will attract, plus Q will repel. Net electric field will be in this direction, equatorial, and how much will be that? You have to find properly by using the angles, and when you solve it and get, then E equatorial will become equal to K P R divided by R square plus D square whole power 3 by 2, and minus P cap is direction. Am I right? Why minus P cap? Because electric field is in this direction and dipole moment is in this direction. So, for representing the direction of electric field as opposite to dipole moment, I am putting a negative P cap here. Derivation, you should do this, they will cut marks otherwise. And once again, if R is much more than D, what will happen to electric field between the equatorial point? It will become K into P by R cube. So, for R being much bigger than D, E axial is always equal to twice of E equatorial. I hope you are understanding this. Very basic thing. And if you are understanding this, then let us take some questions from the previous papers. The first question, 1 mark question. It's a 1 mark question. Tell me the answer. Obviously 90 degree. Just now I told before some time. Maximum torque when it acts, when theta is 90 degree. Simple, very simple question. Next question you see. First part you leave, derivation is there. Second part, can you draw the graph and show me? It is a 3 mark question, 2 mark for the first derivation and 1 mark for the graph. This is a board question which is a 3 mark question. First derivation is very simple. They are asking you to derive for which point? Axial point. And they are asking you to draw the graph. Anybody has drawn the graph? Why 2 lines you are drawing, man? Mistake. That is almost correct. No man, why parabola you are drawing? Is it y is equal to 4x square or something like that? Y is equal to x square? No, right? What is this graph first of all? For axial point, what will be E?
1 by R.
Kp by to k 2p by r cube, or maybe whatever equatorial point also k by r cube. So it will be E proportional to 1 by r cube. Am I right? For this graph, those who don't know, inverse cubic graph, it will be like this, isn't it?
In the square also.
Will be similar to this. Actually, if I draw very exactly, in mathematics terms, it will be like always obviously meeting like this, something like this. Exact graph if I am drawing, isn't it? But we cannot take only positive values, so we can draw like this. Understanding? 1 mark for this graph. Remember that. Shall I go ahead? Next question you see. 1 mark question MCQ. Fine, fast, simple question. Simple question, solve it fast. Q they are asking you, everything they have given. Very basic question. Make it fast, guys. Very basic question. Electric field is given, torque is given, angle is given. Solve and tell me the answer. Option C. This quick mistake will be there. Solve it, man. You don't want to use this?
Sir, option A.
Option A. Anybody else? A only. A. A. Okay, what is the formula of torque? Torque is equal to P E sin theta. What is P? Q into 2D. Now 2D is the distance, don't take it multiply by 2 and all, into E into sin theta. So Q is how much? You want to find that. What is tau value? 8 into 10 to the power minus 3. What is 2D value? 2 into 10 to the power minus 2. What is electric field value? 2 into 10 to the power 5. What is sin 30? 2 gets cancelled. When you solve this, 2 it will become 4 times, minus 3, it will become minus 6. So obviously 4 microcoulomb. Simple question, isn't it? Simple question obviously, you should not say it is tough question. Any problem? Any mistake you did? Next topic. Yes. Next topic is electric flux. I said now we have come to the most important part of this chapter. That is, see last 10-year paper also, you will realize that the most questions have come from electric flux, Gauss law in the board examination. So you have to be very strong in this, and I will show you how the questions are coming from this topic. Okay. What is flux? Flux is dot product of what and what? Electric field and area vector. It can be said theoretically as number of electric field lines passing normally through an area. So this electric flux phi is equal to E vector dot A vector. Since it is the dot product of electric field and area vector, it is a scalar quantity. Electric flux is a scalar quantity. Always remember this. One more thing is, electric field, what is the unit? Newton per coulomb. Area, what is the unit? Meter square. So what will be its unit? Newton coulomb inverse meter square. If somebody is saying electric field is volt per meter and area is meter square, then it will become voltmeter. So the SI unit of electric flux is Newton per coulomb meter square or voltmeter. Both are correct. Again in board exam this question has come. What is the SI unit of electric flux? That option was not there. Voltmeter was there, Weber was there. Many children will tick Weber and come. And Weber is only for magnetic flux, not for electric flux. Okay. Next, electric flux, I am saying it is a dot product of electric field and area vector. If I write it further, it will become EA cos theta. Now what is theta here? Angle between what and what? Angle between electric field and area vector. Now what is area vector? Perpendicular drawn on the area. For example, if you have this area of a cube, how many faces a cube will have? 6 faces. So 6 faces of the cube means this will have a flux, this will have a flux, this will have, I'm drawing the area vectors. So there are 6 area vectors possible, isn't it? Top, bottom, right, left, front, back. 6 faces will have 6 area vectors. Okay. Now, if the electric field is like this, then you can very clearly see that in this electric field, if I am taking the area vectors as right side, I am taking it as A1 cap, left I am taking as A2 cap, top I am taking A3 cap, bottom I am taking A4 cap, towards me I am taking A5 cap, away from it I am taking A6 cap. So you can see very clearly that A3, A4, A5 and A6 are perpendicular to electric field. Am I right? Electric field in this direction and this A3 above perpendicular, A4 below perpendicular, A5 towards you perpendicular and A6 away from you perpendicular. But A1 and A2 are parallel or anti-parallel. Am I right? So if I want to find the flux of it, this is the electric field direction. So flux will be only because of flux due to the first phase and flux due to the second phase. Because 3, 4, 5 and 6 will produce no flux. Now, what is the value of phi 1? Phi 1 will become equal to E into A. Anyhow, A1 and A2 will have same value because both are squares, cube it is. So, EA cos 0 plus EA cos 180, can I say? Because it's parallel, area vector, electric field same direction. Here area vector opposite, electric field straight, 180 degree. So what is cos 180? Cos 180 is minus 1. So once again it will become EA minus EA equal to how much? Always remember that when a symmetric object is placed inside the electric field, it will have zero flux. Not only this shape, if I would have given a cylinder or if I would have given a sphere, any object if I give which is placed inside uniform electric field, what will be the electric flux? Zero. This face will have plus, this face will have minus, this face will be perpendicular, net value will be 0. Are you understanding this? This is about electric flux. Is it clear to you? Let us see how the questions will come in the examination. See the first question. A very good question, MCQ type, 1 mark. A square sheet of side A is lying parallel to XY plane at Z is equal to A. The electric field in the region is CZ square K cap. Electric flux through sheet is how much? Remember the answer? It came in school exam. Then? A square. A square into A square will become A power 4 and C is there, so clear, okay. Actually, I think it is right answer also. But how will you solve properly if the question comes? Yeah, what you are saying is correct, good. X, Y, Z, isn't it? X, Y, Z. I am taking XY plane as this and Z I am taking here. So, a square sheet of side A is lying in which plane? XY plane, like this, right? Do you agree? Of side A. I am taking the concept wise. You are saying what you are saying is correct only, obviously. And they are saying electric field is in the region CZ square K cap. It means it is in this region, isn't it? That's how the electric field is. Which direction? Z direction, right? And what is the area vector? In the same direction. A cap, and this is electric field vector. So what will be the flux? Flux will be E A cos 0. Now what is E? Electric field is CZ square and Z is equal to A, obviously given. And what is A? Area is A square. So answer will be C A power 4. What is that value? A is the answer. A power 4C. Simple question. Isn't it? Clear? Very basic question. Now let us increase the level. After Gauss law it will come, I think. Yeah. Let me talk about Gauss law also. What is Gauss law? Gauss law is another way of finding flux. But for what? For the charges. In the previous case, when I talked to you about the flux, if you see the previous page, then I have talked to you the flux for electric field lines. I am going to talk about the flux for a particular charge that is enclosed. Now we have come to the last topic of this chapter, the most important part of the chapter. I said to you, questions are coming mainly from Gauss law only. How questions are coming, we will see. But first you understand what is Gauss law. Gauss law says that the flux which was equal to the dot product of electric field vector and area vector is also equal to Q net by epsilon naught. Theoretically, how he says? He says that the net flux produced by any charge which is enclosed by an Gaussian surface is 1 by epsilon naught times the net charge enclosed. I will repeat, the electric flux produced by any charge which is enclosed by a Gaussian surface is always equal to 1 by epsilon naught times the net charge enclosed. Now the question is, what is Gaussian surface? It is an imaginary surface which must enclose the charge. It can be of any shape, but it must enclose the charge. Okay? So if you have some charge, if you are enclosing it by a sphere or by a cylinder or by a cube or by a cuboid, it can be called as Gaussian surface. right? That is a theoretical explanation. Mathematically, phi is equal to q net by epsilon naught. That is a Gauss law. Now, once again, there are two things in this topic. One is about cube, the charge placed in different parts of the cube. Second is the applications of Gauss law. There are three applications, and all three are important. So first is, if I take a cube, see here, please. If I take a cube, they may ask you, what is the net flux produced if a charge q is placed in the center of the cube? What will be the answer? Flux through cube will be how much? Why? It's just q by epsilon naught.
Q by epsilon.
That's a q by epsilon naught. Point charge in center symmetrically placed. Yes. I am talking about, you are saying about each phase. If they ask for each phase, it will be how much? 5 by 6. 1 by 6 times of q by epsilon naught. Why 1 by 6? 6 phases. Each phase will take same share. So 1 by 6, 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 1 by 6. Totally 6 by 6, that is 1 q by epsilon naught, isn't it? So flux through each phase will be 1 by 6 times of q by epsilon naught, and flux through cube will be q by epsilon naught. Same charge, if it is shifted to where? One of the faces. Suppose here. Yes, why q by 2 epsilon naught? Because you have to draw another cube like this, isn't it? Only then it will become symmetric. Then you will get the value of flux phi as q by 2 epsilon naught for each cube. For each cube. And for each phase how much? 1 by 10. Why 1 by 10? Because q by 2 it is taking, and this phase will not be considered. Whichever side the charge is enclosed, that phase will never be considered. How many phases remaining? 5 phases remaining. So it will become 1 by 5 times of 1 by 2 q by epsilon naught. The answer will be q by 10 epsilon naught, isn't it? Third scenario is, if the charge is placed at one of the edges like this, then how many cubes you need? You need 3 more cubes to make it symmetric. For example, a cube is maybe required like this, isn't it? Behind it and here. So how much each cube will get? Each cube will get 1 by 4, no man, how you 3? 4 cubes are there, so it will become 1 by 4 times of q epsilon naught. And how much each face will get? 1 by 4 times of 1 by 4, isn't it? Why I am taking 1 by 4? I said you, how many charge it is attached, it will be neglected. So in this case, if you see out of these 6 faces, this charge is getting attached with this face as well as this face. These two will be neglected, remaining are only 4. So 1 by 4. So how much it will become? 1 by 16 times of q by epsilon naught, flux through each face. And the last one, when the charge is present where? At the vertex. How many cubes you need then? 7 more you need. Yes. If the charge is present at the vertex, then you need 7 more cubes you need to make it symmetric. Maybe 1 cube like this, another cube like this, another cube like this. Once again, same set above also, isn't it? Then only it becomes symmetric. So each cube will have how much share? Each cube will have a share of 1 by 8 times of q by epsilon naught. And what will be the flux through each phase? 3 will be neglected, so it will be 1 by 3 into 1 by 8 will be 1 by 24 times of q by epsilon. Whatever I have told is very important now. That is, charge present in the center of the cube, charge present on the face of the cube, charge present on the edge of the cube, and charge present on the vertex of the cube. For each case, you will have different flux. You should remember the flux through the cube as well as flux through the face. If you see NCERT, one question is there, and that question has come in the board exam also, where they have not given directly. How they have given, you know? there is a square plate. I'll take a black. Yes, they have told there is a square plate and they have told some d distance away above it, and they are asking what is the flux through this face. What will be the answer? What will be the answer? Charge is present 1 by 6 times of q epsilon naught. Obviously, because if you keep 5 more squares and make it as a cube, then all the full cube will have cube epsilon naught, and on one face you will have 1 by 6 times of cube epsilon naught. This kind of question can come in the board examination. So whatever I have told you, it may not come directly, it may come indirectly. Then comes the distribution of charges. That is, if you have linear charge distribution, lambda q by L, isn't it? So for linear charge distribution, what is the electric field r distance away by using Gauss law? You will take a cylindrical Gauss law, isn't it? Remember this. Then you will find the area vector A3, A1, A2 will be perpendicular, so it will be 0 flux. This will have flux. When you solve, you will get the value of electric field is how much? Lambda by 2 pi r epsilon naught. I hope you remember this. How derivation is done? Derivation is done because this face will have area vector in this direction, A cap. This face will have area vector below, A cap, and electric field will be like this, outwards, isn't it? So electric field will be in this direction. Area 1, area 2 are having 0 because cos 90 is 0, and there will be only one area, area 3, which will become equal to 2 pi RL. So first you will use Gauss law and then you will use normal flux formula, equate both, get this answer. Same way, for a charged sheet, r distance away, what is the electric field value? Sigma by 2 epsilon naught. How we have derived this? We have once again taken a cylindrical Gaussian surface and then we have found the electric flux by using the EDA cos theta. We have found electric flux by using Gauss law, equate both, you will get this answer. This also helps you to understand how we create a uniform electric field. So suppose I am having a plus sigma plate, a minus sigma plate, between them electric field is uniform, and what is the value? Sigma by epsilon naught. Outside electric field is 0, here also 0. And then we have talked about a spherical shell, and in spherical shell, if you have a charged spherical shell, then the electric field due to it at a point outside will be how much, on the surface how much, and inside how much. You should know these values. At outside, the value will be how much? Electric field will become equal to k q by r square. R is this R. It is capital R. Electric field here will become equal to k q by r square, and inside there is no charge enclosed. Electric field will be 0. This question has come in the board examination. Derivation of it is very important, and it is not the only formula you have. In terms of sigma also we have. How much is that? What is the value of this? Sigma by epsilon naught into r square by r square. You check, this formula is there. And here it will be sigma by epsilon naught. One more thing I will tell you. They may ask you indirectly question. One question has come in the board examination. They have asked like, prove that the charge on a spherical shell behaves as if the charge is concentrated in the center of the sphere. So, if you have a spherical shell, then the electric field at external point is kq by r square. Same charge q, if it is present in one point and you go r distance away, what is the value of electric field? Kq by r square only, isn't it? So, we can prove that if the same charge is concentrated in the center of the cube, center of this shell, it will have the same value of electric field as that produced on its surface. Okay? With all these basic recall of the concepts, if you see the questions that has come in the board examination, the first one you see. Some 3-4 questions are there, let us see. Yeah. The electric flux through a closed Gaussian surface depends upon what? A, B, C or D? C, net charge only. What is the formula here? Phi is equal to Q by epsilon naught, am I right? So Q net also, and what about this Also right. So answer is what? Okay. It has come in 2020 board paper. Next question you see. Interesting one. Solve it and tell me the answer fast. It's a 5-mark question. In the board examination, 5-mark question. Electric field is uniform and acts along the positive x direction in the region of positive x. It is also uniform with the same magnitude but acts in the negative x direction in the region of negative x. The value of field they have given for x greater than 0. Huh? Check, solve. I don't think. See properly. Second one 0. If Q is 0, then flux also will be 0. Solve it, solve it. Always the answer will not be 0, man, not 0. See properly. Solve this question. That is not 5-mark question, this is. Read the question properly. It's a very interesting question. Not like how you are thinking. Are you solving or you are waiting for me to solve? Solve fast. February is the exam, physics, right? My Balan, don't forget that. For all the other exams, for you also, Pavan, for all the other exams, you have the number of days, right? For math, you have 10 days, 8 days leave. For computer science, you have this much days leave. For English, you have this much days leave. But if I ask you how many days leave you have for physics exam, how much you will say? 3 days. So you are taking it as 3 days. How much days you have for physics examination? It depends when the school leaves you, right? 20 days also you can say. Sir, my school is getting over by January itself. 20 days I have. But you are starting preparing only on 15th. Then 6 days only you have. 5 days only you have. If you wake up on 20th, then no day you have. So it depends upon when you are starting. For other subjects, you have limitation. 8 days, 7 days, 6 days. Physics alone this time, it is very surprised actually. They have never done physics exam in February month. Always it goes in March. Because they will start with English only. This time they started with physics, I don't know why. So there is no number of days for physics exam. It all depends upon when you start preparing for it. Be aware, question paper can be anything, tough, easy, anything. If you're not prepared well, it will demotivate you. So prepare well for the examination. That's why we are keeping all test series for you. Take it seriously. Okay, have you solved it? They have told very clearly that cylinder is placed like this, isn't it? 10 centimeter this side, 10 centimeter this side. Also they have told you electric field is 200 Newton per Coulomb in this direction if x is equal to 0 and 200 Newton per Coulomb in the opposite direction when x is less than 0. Am I right? So it will not be 0. The electric flux will not be 0 for sure. Simple question actually. What will be the value of flux then? E A cos 0 plus E A cos 0, because electric field area vector parallel. Here also electric field area vector parallel. So what is the flux value? 2 E A, that's all. And what is the value of, okay, 2 into what is the electric field? 200. What is the area? Radius is given 5 centimeter. So pi into 5 into 10 to the power minus 2 the whole square. If you solve this, you will be getting this much Newton Coulomb inverse meter square as the flux, not 0 guys. And since flux is equal to Q by epsilon naught, then Q net will become equal to whatever value you got, you have to multiply with 8.85 into 10 to the power minus 12 and you will be getting the answer. Is it clear to you?
So, but
Yes.
why didn't we take the negative sign of the electric field which is in the negative axis of the x-axis?
Okay. Electric field is vector quantity, by the way. Negative sign indicates that it is in the opposite direction, nothing else. Are you getting? Or if you take negative 200 into area into cos 180, it will become how much? Once again positive. Okay.
Okay.
I hope you have understood this question. 5-mark question this is. First find the flux and then multiplying flux with permittivity of free space to get the value of net charge enclosed. I hope it is clear. Next question that has come in the board examination. See. 2-mark question, very simple question. Say the answer fast. 2-mark question in the board exam. Came last year, and in 2023 it came. Say the answer. (2023) compartment exam question this is. What, Punaditya? Compartment. 2025 compartment. Who will write? What, man? Study, man. Don't come to the Nilamaya of writing compartment exam and all. And believe me, it's not like compartment will be easy. It will be also tough. I hope you are aware what is the meaning of compartment examination. They are calling it as compartment. Huh? Tell me, man. Yeah, Birti, tell me.
Q1 by Q1
Q1
minus Q2.
Good, correct, very good. The answer is Q1 by Q1 minus Q2. I hope you understood how. It's not solved still. So there is a charge Q1 and it is enclosed by a sphere of radius R1, right? There is another surface bigger than this and charge here is minus Q2, right? This is the question. Q1 and minus Q2, right? What is the flux by this surface? Phi 1 will become equal to Q1 by epsilon naught. What is the flux through this phase? Phi 2 will become equal to Q1 minus Q2, add both, right? So Q1 minus Q2 by epsilon naught. Divide both, Phi 1 by Phi 2, that will become equal to Q1 by Q1 minus Q2. Simple. 2-mark question. Are you waiting how the question is coming? First surface, what is the charge enclosed? Q1. Second surface, what is the charge enclosed? Q1 minus Q2. Because we are adding algebraically all the charges. Next question. Say, see, I told you this question is coming in the board exam. What I told before some time. Apply Gauss law to show that charged spherical shell, the electric field outside the shell is as if the entire charge was concentrated at the center. All India, 3-mark question. What they are asking indirectly? Derive the Gauss law's application, third application. Are you getting? If you are not knowing that, then you will leave this question and come. What is this? I don't know. It's very simple. Third application of Gauss law, you have to prove that E is equal to KQ by R square. Can I proceed further? Okay. Next question. Once again, very common question, where you have plus sigma, here you have minus sigma. They are asking you to find between the sheet. I told before some time, what is the value of this? Sigma by epsilon naught. Here how much is the value? 0. Here how much is the value? 0. But it is a 3-mark question once again. Derive all these things. So plus sigma, you are having even this side, like this side, should solve it and get the answer. If you have doubt, you can ask me later. Okay. Next. Last question I think. Last for today. Solve and we can finish the class today. 5 mark board, last year board paper. See, 2024 5 mark question came from this chapter only. Last year 5 mark question from this chapter. Not visible.
So could you read the first line of the first question?
Using the Gauss law, show that the electric field at a point due to uniformly charged infinite plane sheet is given by sigma by 2 epsilon naught. You can leave that part. Derivation they are asking for the second application of Gauss law. Second part you solve. Electric field is given as 5x square plus 2 I cap. 5x square plus 2 I cap. And then what they are asking you? They are asking you to find the electric flux through the cube and net charge enclosed by the cube. Flux and Q they are asking, electric field is given and dimension is given. Electric field is changing, it is not a uniform electric field, it will not be zero electric flux. It is changing because X is changing. Simple question, like NCERT example question only. In NCERT an example question is there, not the same but similar question is there. Solve it fast. You are going to finish, make it fast please. I cap means electric field is in this direction. What is the value of electric field? 5x square plus 2 I cap. Okay, this color is now they are asking you to find electric flux. How will you find? These four phases will be 0, only right left. Right, what is the area cap? This is the area cap here. They will be same and 10 centimeter means it will be 0.1 square, isn't it, area. So flux through this cube will become equal to phi 1 plus phi 2. What is the value of phi 1? I am taking this as phi 1 and this I am taking as phi 2. So phi 1 will become equal to E. E will become equal to how much? Where is the origin? Huh? So X is equal to 0. So it will become only 2 electric field, isn't it? 2 into A, area is how much? 0.1 into 0.1, 0.1 square. Into cos how much? Cos 180, isn't it? Plus, for this point X will become equal to how much? 2, no, side is how much? 10 centimeter, so 0.1. So electric field will become equal to 5 into, at this point the electric field will become equal to 5 into 0.1 square plus 2. Am I right? Solve this. When you solve, how much you will get? 0.1 into 0.1 will be 0.01. 0.01 into 5 will become 0.05. 0.5 into it will become 2.005, isn't it? Electric field value, and multiplied with A. Area will be once again same, which is 0.1 square, and cos 0. If anybody has doubt in this, ask me. What I have written on the board is the answer for the first part. And when you solve it, I can take common outside 0.1 square if I take common. Then it will become how much? 2, actually minus 2 plus 2.005. Can I write like this? So answer will be, flux will become equal to 0.01 multiplied by 0.005. Very small value is coming. I hope you are understanding what I am doing. So, this will become equal to 0.00005. How much is that? 5 into 10 to the power minus 5, isn't it? Newton. What happened, man? One more zero will come, huh? Any issue, others? Some mistake is there, tell me. Is it clear to you how the answer has come? And then multiply this value with 8.85 10 to the power minus 12, you will be getting net charge enclosed. I hope it is clear whatever I have told. So in today's session, I could help you in understanding last 5 years what are the different types of question that has come in the board examination. 2 point? Okay, so 1 0 will reduce. 0.1 will become 0.01. 0.01 into 5, yeah, 1 0 will reduce here. Yes. Yes, so it is 0.5, so it will become 1 0 less. Sorry, 1 0 less, it will become minus 4, isn't it? Got it? So anyhow, what you are understanding from today's class is just the questions that has come in the past papers. So please make sure that you are revising the chapter and solving the NCERT book back question, example question, everything should be ready by now. Same way, in the next class we will take the second chapter. Second chapter also, my full focus will be to take all the 5-year papers in the last 5 years, whatever questions have come in the board examination. Okay, we will solve it and then we will move to the further chapter.